warmly a very good evening to everyone present here, to Professor P.K. Ahluwalia ji, President IAPT, Professor H.K. Shahzwani, President RC01, Professor Nasir Iqbal, President RC24, Professor Meenakshi Syal, President North Zone, and all respected dignitaries, esteemed guests, faculty members, and their participants. It is really my proud pleasure to welcome you all to today's program. We are honored to have such distinguished personalities with us. This workshop, Mechanics Beyond the Formula from Force to Frames of Reference, aims to go beyond formulas and build deep conceptual understanding of physics. We are delighted to have enthusiastic participations from educators across the nation, making this a truly diverse and enriching learning platform. To begin with, I would like to invite Professor Meenakshi Syal, convener of the program. She is former Dean, Academics, NAC, and UGC coordinator associated with IAPT for more than 35 years. Presently, Professor Syal is Vice President, IAPT North Zone. She is coordinator of Facebook page, Lucy, an interactive platform to understand and solve the problems of physics. She delivered more than 150 talks as science communicator and selected as mentor by Ministry of Education, Government of India, for mentoring of many school teachers. Professor Syal is recipient of prestigious international and national awards, including World Book of Records on YouTube channel To Reach the Unreached. Ma'am has been a dynamic and dedicated contributor to various initiatives of IAPT, playing a vital role in advancing physics education. Ma'am, we request you to present a formal welcome address of the workshop.
Thank you, Dr.
Thank you, ma'am.
Neetu. Thank you. Thanks a lot. Honorable President, Professor P.K. Ahluwalia, our respected guest of honor, Professor Nasir Iqbal, Dr. Kuldeep Sharma, Professor H.K. Sahajwani, our resource persons, Mrs. Pragya Nopany, Mr. Jeevan Pandey, Mr. Sahu Basu, our coordinator, Dr. Neetu Verma, and very enthusiastic participants, good evening to all. Dear participants, it gives me immense pleasure to welcome you all in this prestigious and innovative workshop. Total 66 participants, not only from all regions of India, but also from abroad, are the key pillars of this workshop, Mechanics Beyond the Formula. I am delighted to see such an enthusiastic gathering of learners, educators, and curious minds who share a common interest in exploring physics more meaningfully. The primary aim of this workshop is to create and strengthen competency among students in the subject of mechanics. In today's learning environment, it is not enough to simply know formulas or solve routine problems. True competency comes from a deep understanding of the concepts, the ability to apply knowledge in new situations, and the confidence to think critically and independently. Through this workshop, purpose is to move beyond traditional approaches, not to just solve problems, but to understand and approach creatively. This platform has been designed to encourage active participation, discussion, and exploration. I urge each one of you to make the most of this opportunity. Engage wholeheartedly, ask questions, and collaborate with your peers. Remember, competency is built through practice, curiosity, and willingness to learn. It is an honor and privilege to extend warm welcome to our President Indian Association of Physics Teachers, Professor P.K. Aluwalia. Sir, we are truly honored to have you with us today. Your vast experience and valuable contributions are an inspirational to all of us. In person, I tell you all that there is always continuous guidance and motivation of Sir for the success of each endeavor. It gives me immense pleasure to warmly welcome the esteemed presidents of different regional councils of North Zone. Your presence reflects your commitment to collaboration, knowledge sharing, and strengthening our collective efforts. My special thanks to Professor Nasir Iqbal, Registrar, University of Kashmir, for accepting the request for inaugural address. I would like to extend warm welcome and my sincere appreciation to the resource persons, Mrs. Pragya Nopany, Mr. Jeevan Pandey, and Mr. Sahu Basu. Your expertise, experience, and dedication to the subject will bring immense value to this workshop. Your contribution plays a vital role in making this workshop meaningful and impactful. Thanks to my colleague, Dr. Neetu Verma, coordinator of the workshop, for all technical support, and we both can together bring this workshop on this very platform. Thanks to all. Thank you very much. Thanks to God. Thank you.
Thank you, ma'am, for your warm and inspiring words. Before we begin, may I request all the participants to kindly introduce yourself in the chat box by mentioning your name, designation, and institute. This will help us know each other better and make the session more interactive. Now it is my proud privilege to invite member of organizing team of the program, Professor Nasir Iqbalji, President RC24 and Registrar University of Kashmir to deliver the inaugural address. Before I invite such, let me briefly introduce Professor Nasir Iqbalji is a distinguished physicist and academic administrator with over 2 decades of experience. He is serving as a professor in the Department of Physics at the University of Kashmir since 2016. His research areas include large-scale structure of the universe, X-ray astronomy, and high-energy astrophysics. He has published around 50 research papers and successfully completed several major research projects funded by agencies like ISRO, DST, and BRNS. He has been associated with Inter-University Center for Astronomy and Astrophysics as a visiting associate for many years. He visited China, Egypt, UAE, Singapore, Europe, Iran, Kuwait, and many other countries for attending conferences and invited lectures, and developed foreign collaborations with the scientists from Kuwait and Egypt. He is a recipient of prestigious Indian National Academy Teacher Award 2021. Sir, we humbly request you to share your valuable thoughts with us. So we are really privileged with your presence. Over to you, sir.
Thank you. Good evening. Am I audible?
Yes.
Yes, sir.
Okay. So good evening, Honorable Professor P.K. Aluwalia ji, the President of Indian Association of Physics Teachers, Professor Meenakshi Sahil ma'am, the convener of the workshop, and then other physicists who have joined us. An important component of today's event are our dear participants who have joined throughout the country. And I was going through the stats, even many of them Few of them have joined even, some of them are from UAE. So I'm very happy to know that we have to believe that the subject of science is not done at the national level, is not done at the regional level. It is always done at the top level, means at the world level. Because science is the subject which always connects people from one country to the another. Now coming back to the title of the workshop, the mechanics beyond the formula, from force to the frame of reference. As the professor of physics, I believe that the title of the workshop has been well chosen, keeping the scope of the subject in recent times into consideration. I will not, I think it's important to tell here that the subject of physics has revolutionized the whole science from time to time. Whatever, whether we talk about any topic, whether it is the Newtonian mechanics, whether it is the quantum mechanics, whether it is the solid state physics, whether it is the material science, whatever it is. But at the same time, we have to believe that when we see the students opting the physics, particularly at college level as well as university level, has drastically gone down. We have to admit this fact. Because unless and until we will not admit this fact, we will not be able to find the solution. In fact, we as a teachers have to find the solutions. There can be, of course, there are other challenges. Maybe the dynamics of the system have changed, the job profile from time to time have changed, the availability of the jobs have changed. But at the same time, we believe that the physics is the subject which is the queen of all the sciences. When we talk about the biology, when we talk about the medical science, when we talk about the engineering science, whatever the science we'll be talking about, all of them have directly or indirect relations with the subject and the scope of this physics. I was going through the important topics that have been chosen for all these days of six days workshop. It's related with the systems, the forces, the assumptions, the energy, the rotation, the many body constraints, the validity of Newtonian mechanics, means Newton's laws, and the frame dependence. See, I remember during our times, I will say that before 20, 25 years, when we were the students, that time taking physics as an option, as a career, was one of the top careers in the scientific evolution. So this trend has little bit changed. Is there a change in the curriculum? Is there a change in the teaching methodology? Are we teachers uh, capable of teaching the subject in a very professional way? I will say that that is a matter of debate which cannot be discussed right now. Of course, as being the president for R24, RC24, maybe at regional level, we will definitely like to have sometime a seminar on this, that what as a teacher we should do to interact more and more younger minds towards the scope and the subject of the physics. I believe that not only now, but from the very beginning, there are always very excellent physics teachers, because anyone who has chosen physics as a career definitely would have worked very hard to teach the physics in a very professional way. The topics that we will be starting right from today for all these 6 days will definitely give some an excitation, rather and very amplification kind of the thing, so that as teacher or even as a student we will be able to see that how and what are the challenges in taking these subjects or in taking these topics or in teaching these topics to our students. We have been always talking about the force and the frame of reference right from the beginning, and then the inertial frame of reference from the very beginning, from the fundamentals of the physics. We have been talking about the inertial frame of reference. We have been talking about the theory of relativity. We have been talking about the special theory of relativity, leading to then to the gravitational theory of relativity. When we see at the top level and see what are the very important topics where our research scholars, not only at the national level, but also at the global level, are doing very, very great work. For example, I talk about the gravitational waves, which have a base of the general theory of relativity. I have seen that in our country, we are coming up with one of a great detector, namely LIGO India. And I have been told by my friends who are directly working for the detection of these gravitational waves that they need a very, in a very good number, the scientists, the physicists, the engineers who will be associated with this project. I am sure that at national level, very good projects are being funded in the discipline of the physics, be it related with the astrophysics, be it related with the theoretical physics, be it related with the observational physics, be it related with the experimental physics. Naturally, it's all we physics teachers who have worked hard, who have to work hard, and who have to share their expertise towards our student fraternity. Because as being the teacher of the physics, it's my duty to spread the message of the discoveries that the great scientists have been doing or have been making in the discipline of physics from time to time. The role of Indian Association of Physics Teachers is very important. IAPT has done a very great job from last several years, but there is a huge responsibility on this IAPT to do more, because as I said that there are challenges nowadays. Our very brilliant minds who can excel too much in the subject, in the scope of the physics, sometimes they choose a different path. They go to the management, they go to the civil service, they go to the other kind of exams. I'm not against that. That's a very welcome step. Everyone has every student has a freedom to choose for his or her career. But at the same time, the country is progressing in its science, in its every development. We are doing wonders at national level. So I mean to say that by doing such kind of workshops, by spreading very good lectures, by popularizing very good lectures among the student community, among the teaching community towards the subject of the physics is always a welcome and should always be welcomed. Because I would definitely congratulate Professor Meenakshi Sahil ma'am, who has been on the forefront and had been doing lot of efforts to assemble the participants at the national level, particularly. I have a word with Professor Meenakshi Sahil ma'am some days back, and I definitely will like, on behalf of the RC24, I definitely will like to congratulate all of you people who have started these efforts to popularize the subject, and particularly when we see the topics that have been chosen in this 6 days workshop definitely covers the fundamentals of the physics. Because as a teacher, when we teach the first thing in the physics to a student, we start with the system, we start with the force, we start with the inertia, we start with the axis of rotation, we start with the movement of rotation. So we start with the many body problem, we start with so many things. So of course the teachers are well trained. That is why we teach physics to the students. But at the same time, there is always a scope, and particularly the experts like Jeevan Pandey sir and others who will be part of all this workshop for all the days, definitely have a high expertise in teaching these fundamentals of physics, and definitely it will enhance the capability in understanding the things in a more professional way, in a more technical way, so that we will be able to reach the students in a very, very friendly way and guide the students. It's not only the teaching part of our duty, but at the same time to mentor the student in taking the subject as a physics, in choosing the physics as a career is our biggest responsibility. With these words, I feel that it's honor to be a part of this great event, and I would definitely like to listen all these lectures. Although I have presently I am the registrar of the university, so there are other assignments, but I will definitely like to have to be a part of this these important lectures, so that at least even if I am a professor of physics, but I believe that I know that you are never complete. You have always to study. There is always a scope to know more and more. Even going with a very simple term, the system, when I teach the system as a definition to my students at the master's level, I always give them a very appropriate answer. A system is a very specified part of the universe put for an investigation, or which is subject to an investigation. So maybe when I will definitely like to have the expert lectures, it will enhance my knowledge, because listening the lectures and participating with the lectures is always, it will always help you in one way or the other. So I don't want to take too much of time, because we will definitely like to have the comments, and also the comments of our honorable president, and definitely then the expert lectures will follow. So I will definitely like to give space to that. But at the end, my thanks to all the people, particularly the honorable president, the convener of the workshop, and then the expert talk to be delivered by Mrs. Pragya ji and others. Is I'm thankful to you for inviting me to be a part of this workshop. With these words, I will definitely like, since I belong to the valley of Kashmir, which is a crown of the country. So sometime in near future, we would definitely like to have a kind of the workshop for IAPT in Kashmir Valley, where we will be able to invite all of you people and see the beautiful valley and discuss the beautiful subject in the valley itself. Thank you very much.
Thank you, sir, for your so insightful and motivating address. Now, it is a matter of immense honor and proud privilege for me to invite our very esteemed President IAPT, Professor P.K. Ahluwalia ji, who is a distinguished physicist with extensive academic and research experience in theoretical and applied physics. He has contributed significantly to higher education through teaching, mentoring, and curriculum development. Sir has played a major role in shaping scientific thinking and nurturing young minds across the country. Professor Ahluwalia ji is widely respected for his profound academic insight, visionary leadership, and invaluable contribution to physics education in India. His guidance has consistently inspired both the educators and learners to strive for excellence and innovation. Under his, under his visionary leadership, Indian Association of Physics Teachers has strengthened the mission of promoting quality physics education at all levels. Sir, we feel honored and privileged to have you with us today, and we request you to kindly enlighten us with your kind words. Over to you, sir.
Thank you very much, Dr. Neetu, for your kind words. And I'm really very happy to be part of this workshop. I'm extremely happy to have Professor Nasir Iqbalji from our, I would say, a new regional council of Jammu and Kashmir and Ladakh. We are, I must thank you, sir, for inviting us to the valley. And we are very keenly looking forward to that. And I'm sure that
Surely,
we
inshallah,
can
in your future,
all
surely.
reach there in no time once the invitation lands on our tables. I think today's workshop has been blessed by very many people, I would say. Professor Nasir, your coming is the biggest blessing for us here. Also, I am really thankful to and grateful to Professor Sehjwani, President RC1, Delhi and Haryana. He is one of the, leading persons in the country on very many things which he does even at that age where people forget physics. He is creating physics. I think, thank you very much, sir. Then I must say that we have a very distinguished person with us who has guided very many programs of Indian Association of Physics Teachers, Professor Pragya Nopany. And I think all the participants of this workshop will see what is the meaning of a passionate, committed teacher in her. She is a very distinguished person. She has won President's Teacher Award also. She has also won a very important medal of the IAPT, Professor H.S. Hans Medal. So thank you, ma'am, for curating this program and being the brain behind it. I must tell that the team which is working so passionately is also being guided by a very dedicated woman team, I would say. Ma'am Pragya is one. Second is Ma'am Meenakshi Sayal, a very passionate teacher. She is the face of Let Us Understand and Solve It, the Facebook program or the Facebook page of Indian Association of Physics Teachers, which has completed 3 years of its presence on the internet, and it is targeting its audience particularly at class 11 and 12 level. Then we have Dr. Neetu Verma. She is, in fact, if you go to the web page of IAPT, you will find that she is the brand ambassador of Indian Association of Physics Teachers. I had very many opportunities to work with Ma'am Meenakshi, Ma'am Neetu, and the members of Regional Council 2, which is Punjab. Professor Jaswinder Singh ji is a very passionate, physics communicator, and he doesn't mind, visiting various places on his own by knocking at the doors of various schools. Whenever we have such teams and when they bring such programs, there is no reason why we should not go wiser by listening to their expertise, their insights, and what it means to be a teacher. Now, ever since in 2020, National Education Policy was launched, there was one aspect which was very much into focus. And that aspect was actually on capacity building. I believe as a teacher, I think we need to refresh ourselves again and again and again during our journey as a teacher. And I think we have seen so many changes in the content delivery in the classroom and outside the classroom, which requires definitely very different competencies. But we must not forget that whatever technology can do for us, it doesn't mean that the basic knowledge, the basic understanding, the basic way of presenting things is always crucial. Many times we are hearing that because AI is coming, maybe the teacher is going to become irrelevant. I don't believe in that. It will never happen. Teacher will always be a pivot around whom the activities of learning and understanding will revolve. Nobody can replace it. I feel that artificial intelligence works, but it has to have a very big data set to have few insights. Whereas with a very small data set, human beings can really create wonders. And that is where the role of the teacher also becomes very, very crucial and understandable. And I'm sure that the topic which has been chosen is a very fundamental topic. Many a times, even after an experience of 40 years, I feel that when I hear lectures on fundamental topics, I learn very many new things in that. And that is what I hope to learn in this workshop also. My effort will be there that I join in the evening and try to learn new things, because learning from good teachers is again a blessing. A teacher cannot be replaced by technologies, and you will witness that happening in this particular workshop. I congratulate the organizing team, and they have taken a lot of care in making things comfortable. I would like to tell our dear participants here in this workshop that please join in time, because you cannot afford to miss the things which are going to be talked here. It is one of the first programs which we are focusing in IAPT on competence building. And Ma'am Pragya is a country expert in competence building. I can assure you that you are going to have a great time, and maybe you will then demand that we should have this kind of a workshop every month on a new topic so that new insights may be gained. I wish the organizers and the participants and the distinguished, resource persons who are here, that this is going to be a great, great workshop. I have no doubt about it. Congratulations for participating in it, and spread a good message about Indian Association of Physics Teachers also, because our members are more than 10,000 in the country, and we want to reach all those areas where normally people won't reach. I think that is one of the biggest advantages of the technology, and that is going to really help us a lot in future also. Hope you all to enjoy this workshop. Thank you very much.
Thank you, sirs, for your inspiring guidance and encouragement. Sir's words always reflect deep insight, clarity of thought, and a vision for future of science education, making his address truly enriching for all of us. Thank you, sir. Now we move towards the most awaited segment of today's program. It is my proud privilege to introduce our expert speaker, Mrs. Pragya Nopany, founder, coordinator, BVN IAPT Veshika. Mrs. Pragya Nopany is a nationally acclaimed physics educator and recipient of prestigious National Award for Teacher 2017. The list of awards is so much that ma'am has been designated with the Star Award for Teachers in 2016 by the Directorate of Education, Delhi. Professor H.S. Hans Birth Century Silver Medal 2024 by Indian Association of Physics Teacher. Lifetime Achievement Award 2018 by IAPT RC1. Honor Roll 1993 by Association of Science and Technology Center, Washington, D.C. Best Teacher Guide 1992 to 1993 by Eastern India Science Fair. So many more laurels to ma'am. Ma'am holds an MSc Honours in Physics from BITS Pilani and has over 25 years of rich teaching experience as PGT and HOD at Birla Vidyaniketan, New Delhi. She has conducted more than 600 experiential learning workshops across India and has been actively involved with organizations like NCRT, CBSE, KVs, and Vigyan Prasad. As a subject matter expert, she has contributed to curriculum development, teacher training, and innovative pedagogical practices. Mentored by Padam Shri Professor H.C. Verma, she has been instrumental in transforming classrooms into thinking spaces and promoting experiential and inquiry-based learning in physics. Ma'am, we warmly welcome you to this and we are really honored with your presence. So I request you to begin your session. Over to you, ma'am.
Thank you, Neetu ma'am. Good evening, everyone. Namaskar. और बहुत बहुत gratitude to the most inspiring words that have come from Ahluwalia sir, Nasir sir, and Meenakshi ma'am. And thank you so much. Now, this is an interactive webinar. So in a way, we are all conducting it together. So whenever I ask something, please do respond. Please join me in taking it further. And before you speak, just make sure that you speak out your first name quickly and then make sure that no one else is speaking when you start speaking. Another thing, I'll be using polls quite a bit. So your responses are anonymous, and that means your name is not visible to anyone here. So just choose whatever you genuinely think. And unless I ask, please don't put the answers in chat. And because we are not checking the correctness here, we are just understanding thinking. All right. So let us begin. Let me begin by being very clear about the purpose of this session. So we do often solve problems in class, but what students actually learn is mostly the steps. What remains hidden is how we decide what to do. And this session is about that hidden part. How we build competency through experience, through thinking, and through discussing strategy. So, and especially, how do we support the weakest children in the class? And how do we make this accessible to them? So today I will not focus on difficult problems. I'll be starting with something very simple to make thinking visible, because if students learn how to think, they can handle complexity later. So now let me start sharing my PowerPoint presentation.
Today you can just start and start doing anything.
I'm actually so surprised because मैं तो रोज इसी पे वीडियो
मैम कई बार हो जाता है, डोंट वरी अबाउट इट.
कोई बात नहीं अभी
मैंने बहुत सारे
whatever I can share. अभी क्या शेयर हो रहा है? ये हो रहा है शेयर?
यस
हाँ,
मैम,
इस समय शेयर
प्रेजेंटेशन शेयर होगी आपकी. अब
अब
आप
मैं
इसको मैम ऐसे ही चला लो.
यस
हाँ
ऐसे ही चलाइए.
यस यस यस, ऐसे चल रहा है मैम.
हाँ,
अच्छा पर पोल्स कैसे चलेंगे? वो शायद इंडिपेंडेंटली चल जाएगा, चला के देखना पड़ेगा मुझे. हाँ तो
मैम प्रेजेंटेशन से स्टार्ट करते हैं.
हाँ right. So this is the situation that Varsha holds a spring balance by its ring and you pull its hook downward and stop when it reads 1 Newton. How much force is Varsha applying at that exact moment? So what do you think the answer should be? So now I'll try and launch the poll. Poll क्यों नहीं दिख रहा है? Yes, यहाँ है. Yes. So are you able to see the poll on your screens?
yes.
Yes.
Okay. So just quickly put whatever comes to your mind. Don't take too much time. Just whatever you feel instinctively, you can just put it here. Let's all do it quickly. So we have about 60% people responding. Everyone can join it kindly. Only 67%. Please join. Remember, we are doing it together. 72% more. Don't worry so much about it. Just put it there and we'll not look at the answer right now. We will come back to it. Yes, that's better. 74%. Okay, it doesn't seem to be going further. So let me end the poll here and then show the result. This is the sharing. So 1 Newton is about 63%. More than 1 Newton is 15%. Less than 1 Newton is also 15%. And 0 Newton is also 4%. 2% is not sure. Okay, very fine. So let's stay with this situation for some time. Let's stay with this situation and let me go back to this. Is it visible?
Yes.
Okay. So now the spring balance reads 1 Newton. Okay. So what does this 1 Newton represent in this situation? Take a moment and put your thoughts in the chat. What does this 1 Newton represent here? Okay, so what does this 1 Newton represent in this situation? So we have different answers: tension, gravitational force, force applied on the spring balance, weight that the spring, force which is applied to the spring. Okay, so I'm seeing so many different ways of saying the same thing. Now let's try to be more precise. Okay, so now which force does the spring balance measure? Let's be more precise. Now you look at these options, choose the option in your mind, and we'll go to polls again. Choose the option that you think is most accurate, and then we'll go to the polls. So I go to the poll, and let's be precise. Yes. So here is the poll now. Remember, no one can see who is answering what. So just do whatever, choose whichever you genuinely think is right. Good, good, good. We have reached 60%. Do put in your answer, 64, 66%. So you would like to have at least 90% participation. Okay, we reached 74%. Okay, so 75%. Good, good. We crossed the last questions percentage, 77%. Come on, quickly. So, shall I end the poll now? Okay, so I'm ending it, and this is the result. So 45% force applied by your hand on the hook, 32% force exerted by the hook on the spring, 13% force applied by Varsha on the ring, and 11% force exerted by the spring on the hook. Okay. So before we decide, let us look at this more closely. See, many of us chose force applied by your hand on the hook. That is the answer which has got maximum percentage, right? So where is that force acting? The force applied by your hand on the hook. Where is that force acting? On the hook. So is it about the hook or something else? Is that reading, is it about the hook or is it something about something else? And the spring, what is acting on it? What is acting on the spring? Just one or two responses. What do you think? You'll just take one or two responses. You can unmute yourself and speak out quickly. On the spring, what is the force acting on the spring? Yes. Could somebody speak
The
up?
spring is tied at one end to the hook, and the other end
I'm
is
just
the one where we
asking.
are pulling from.
What is acting on the spring?
So the force that we applied by pulling it to 1 Newton, that is acting on the spring. But
Okay.
because it's also tied to the other end, so it's like a tension will develop on both the sides.
So what inside the spring balance is actually changing when it reads 1 Newton?
Its displacement.
Extension in the spring.
Okay. So which force is exactly acting at the location of the spring?
Restoring force.
That is generated, but what is responsible for stretching that spring? What is acting directly on the spring?
The force applied by us.
Pulling force.
You are applying force on the spring. Where are you holding it from? The spring balance? Where are you holding it from? From the spring, or where are you applying the force?
The hook.
On the hook. So is your hand directly connected to the spring? So the balance actually measures the force acting on the spring, because that is the force responsible for stretching the spring. And the other forces which are equal to it, we infer by applying physics. So that is what we mean by looking at this question in more greater detail. To be more precise, we need to know what exactly is it that is responsible for stretching the spring, which shows us 1 Newton reading. So if you say that the force by your hand is same, which is the force by the hook on the spring, fine, they are equal, but are they same? Is your force directly acting on the spring to make it stretch? So the force by the hand acts on what? It acts on the hook. And the force on spring comes from where? Who is applying the force on the spring then? The hook.
Hook.
Right? Right. So that is what we have to look at in minute detail. Now let me go further. Let me just put it together that what did we do in these last few minutes? We started with a very simple situation, but instead of just jumping, writing out the answer, we first tried to understand what exactly is being measured. And how did we do that? We invited everyone to think through the poll without worrying about being right or wrong. So the idea is that before solving, get everyone into the thinking, especially those who usually stay quiet. Okay, so that was the move that we designed in this session, or that is what we aim to design in our classroom. So let me move further. Now look at this. A student says the force exerted by the hook on the spring and the force exerted by the spring on the hook cancel each other, so the net force is zero. Now my question is, before evaluating this, what should we first clarify? You can look at the options and think of the correct answer that you think is correct, and then we'll go to the polls. So let me go to the polls. There also you'll see the question. Is the poll shared?
Yes,
No, ma'am.
not yet.
Not yet. So all your quizzes. Now this is not. Has someone else shared something? Suddenly the poll is not being shared. I just shared so many polls. Why this has suddenly disappeared? Oh God. Now it's not appearing. We just had this poll. I don't know why it's not appearing. Anyway.
Get some other poll instead of this one.
नहीं, इसी को देख लेते हैं. अभी दिख रहा है स्क्रीन पर?
Yes, yes.
हाँ.
Visible.
तो चलिए आप सब चैट में डाल दीजिए. आप क्या लिखना चाहते हैं आप चैट में डाल दीजिए. कोई बात. So, Neetu ma'am, can you read down in the chat just the options that are coming out?
Yes,
ABC.
most of the options, yes.
Just keep on reading A, B, C, D so that I get an idea because I don't want to switch
And
from.
starting options were nearly 10 to 15 options were A. Then
Okay.
someone has choose B, then Z, then A and B.
Hmm.
And again B, B
Hmm.
and B, then A, then B, A and A.
Okay. Okay.
Again A.
Okay. So let's not rush to the final answer. I just want to ask you first that force by hook on spring and force by spring on hook, right? These are the two forces under consideration. Where is each of the forces acting? So are they acting on the same thing?
I'm on different bodies.
Okay. So now if I focus only on the spring, which of these forces will appear? If I focus only on the spring, which of these two forces will appear there?
The force by the hook on the spring.
Okay. And the other one, does it act on the spring?
No, ma'am.
No, ma'am.
No.
So can both appear in the same force balance? Yes or no?
No,
Can
ma'am.
both appear on the same object or can they appear in the same force balance?
No.
So the statement by the child is not exactly wrong, but it is incomplete. Because when we talk about the net force, we are always talking about the force on something, isn't it? And what is that something here? What do you think is that something here?
The system of the hook and the spring.
Oh, so the system of the hook and the spring, on that system do these forces act?
No, ma'am. When we say the net force is zero, it means I'm talking about the system of the hook and the spring, and then I can say the net force is zero. But when
No,
I'm
but
considering,
how do you know? First of all, so that information is missing. That is what I'm trying to say. That many very often the students say that forces cancel. But what do we want them to specify? We want them to specify the system on which they are considering this net force. And does their being equal and opposite and ensure that the net force on the system is zero? Let us pause and think about that. That if these two forces are equal and opposite, and we consider the net force on the system, does it tell us anything that about the net force on the system of spring and hook?
Ma'am, no.
Yeah. So I want us all to understand this, that when we are saying forces cancel, that depends on what we are analyzing. If we are analyzing only one of these objects, can both of these forces appear together? So
Acting on
before,
two different objects.
yes. So before writing any equation for net force or whatever, we need to be clear what is the system. So let's pause here for a moment and think, what did we just uncover? Many times students will say that forces cancel, but they don't specify on what. So instead of correcting the answer, we are first making the thinking visible. That is the shift that we have to work on. I have not answered anything even once, but I'm sure the questions have done something inside you. They have started more vigorous thinking that have we looked at the system in so much detail? Because our decisions will matter on the detail that we have noticed. So how do we have to approach that decision making? Okay. Now let me move further. Now let's go back to our original question. Now again we are saying Varsha holds a spring balance by its ring. You pull its hook downward and stop when it reads 1 Newton. Now how much force is Varsha applying at that exact moment? Now look at the options once again. Look at the options once again. Let me check if I'm able to go to polls once again or not. Only that question had a problem, or no, I think every question is no more available. So let me go from here only. So now you write the answer in the chat. And check whether anything has changed till now compared to what you thought earlier and what you're thinking now. And doesn't matter if you think the same, that also is very fine. I told you in the beginning only, we are not here to check the answers, whether that is right or wrong. We are here to allow more thinking, more deeper thinking, more minute thinking, and bring that thinking out from inside ourselves. It's not for anybody else, it's for ourselves. All right. So let's look at this carefully. Many of you might have answered what? B? Neetu ma'am, what is the answer?
The answer is B, then
B
A,
Bombay.
then E,
Okay.
again B, then D.
Okay.
Majority has given a B answer.
So now
Few
let
people
me
C
ask you,
also.
1 Newton of what? We looked at that question earlier. What Newton of what? 1 Newton of what? Force by whom on what? Will somebody care to answer? 1 Newton of force by whom on what? We had looked at the answer just a little while ago. So what was this 1 Newton representing? Yes, ma'am?
Answer is force by hook on the spring by some participant.
So they can unmute and answer also. Fine. Force by the hook on the spring. So now, when you chose your answer, which system were you thinking of? Which system were you thinking of? Now you see, we did not specify, but yet we all gave the answer. Did we think of the system before we gave the answer?
So someone has shared that by Varsha on ring, by some other it's by ring on finger.
So if we talk about the force by hook on spring, that is 1 Newton. Okay. If we talk about force by spring on ring, listen carefully. If we talk about force by hook on spring, that is 1 Newton. But if we talk about force by spring on ring, is that also 1 Newton? Think about it. And if we talk about force by Varsha on the ring, what do we need to assume? Just say it in one word. I'm repeating my argument. If we talk about force by hook on the spring, that is 1 Newton. Right? We all agreed on that. Now, if we talk about the force by spring, visualize a spring in your mind. On the ring, is that also 1 Newton? And if we talk about the force by Varsha on the ring, what do we need to assume? Give me one word in the chat box. What do we need to assume? Are there any answers in the chat? Okay, let me check. System. They are one system. Okay. They are one system. By spring on ring not equal to 1 Newton. Varsha on ring, assuming rigid support. Spring has no mass. Okay. So whatever you're thinking, just imagine how you went from the force by hook on the spring, which was given to us as 1 Newton. From there, how did you reach force by Varsha on the ring? So are we assuming it is in equilibrium? Or are we ignoring the mass of the balance? So can we decide the answer without stating them? That is my submission. Can we decide the answer without stating these things? In this question, we never said that the spring is light, but many of us have already assumed it without even noticing it. So just notice, this question did not say it, but we still used it. Equilibrium, is it given in the question? Is it given in the question anything about spring being light? We just assumed it. So difficulty was not physics. It was that the assumptions were hidden. And unless we bring them out, different valid answers will keep appearing based on different assumptions. But that doesn't mean that students are wrong. It means they are assuming different things. Confusion is not because they don't know physics, but because they're not aware of their assumptions, which they are unconsciously taking. And this is my submission, that how is it that we can bring competency unless we think about the design of our classroom? What is it that we are aiming to bring out? How the clarity of concepts will come unless we design on the experience that we are giving. I have designed the experience that I want you to have in this webinar, because I have to plan the situations which will make you experience that struggle yourself that the student has to go, and the kind of pitfalls that are there, that we are not clear, yet we are going ahead and solving everything. Not because we are doing it on purpose, but because we have not thought about it earlier, and now is the time to think about it. Okay. So now let me proceed to the next slide. So let us now organize what just happened. We did not struggle with physics. We struggled with how to frame the situation. Even before we go to the solution, we have to frame the situation. So first step, we must choose the system. We must choose the system. Without that, even net force has no meaning, isn't it? And then we have to specify the interaction, because force is always by one object on the other. So which forces are we going to consider whether once our system is chosen? And then third is we need to state the assumptions. Is the system in equilibrium? Is the mass negligible? What is it that we are ignoring? So these decisions change the answer. And none of these were written in the question, but we still use them. And only then do we write the equations. Otherwise, we may get an answer, but not a meaningful one. So before solving a problem, decide the system, state the interactions, state the assumptions, state them explicitly, and then only apply the equations. So reaching the equations, before that, there is a journey. And do we need to explicitly highlight that journey in our classrooms? Let me ask you one more thing. Does it also matter where are we looking from? What do you say? Please unmute yourself.
Yes.
Yes. Does it matter? Are we standing in the lab, or we are moving with the system, or the system is accelerating? Will that change what we see? Yes or no?
No.
Yes.
Yes. Yes.
Yes,
So
ma'am.
let us hold that thought. We'll come back later to that in the webinar. Okay. Now let me go further. Let's not solve yet. We are not solving the question yet. Now just change the system from spring or the entire balance. Just think of the possibilities. We can take the system to be just the spring, or we can take the system to be the entire balance. What changes in the force we must consider? Just call out one thing that changes. Unmute yourself and please call out. If we change our system, once we consider only the spring to be the system, and then we consider the entire balance to be the system, what changes in the forces we must consider? You tell me just one thing that changes.
Direction of the force will change.
Pardon, sir? Can you be louder, sir? Kindly.
Direction of the force will change if we change the system.
Okay. Which force?
So here we are talking about action-reaction couple.
So
And
I'm saying that if you consider only the spring, which forces will you consider? And then when you go to the entire balance as a system, does any of these forces change now? The consideration of any force changes or remains the same. Will you say the same forces are acting on your entire balance?
no.
So give me name of one force which will not be there or will be there but earlier not there. What is the change in one force that you can tell me?
So spring, so balance is also having the hook. So we need to take care of the hook as well. How the forces are interacting with the hook as well. If we
No,
talk
but
about
when we are choosing spring as our system, on what will we see the force? I invite everybody to please participate. When you're choosing spring as your system, then which force should we be talking about? Which force should we select for consideration?
Force acting on the spring.
Acting on the spring. And then when you're thinking of the entire balance, will that force appear in the new system to be acting on the new system or not?
no.
Where will it disappear? Why will it disappear?
Ma'am, forces will not change. It depends on which system we are studying. So then we will look on the forces which are acting on that particular system only.
So if we take the spring, forces at both ends appear or not? Yes or no?
Yes, ma'am.
So what are those forces on the spring? On one side, it is the force by the hook on the spring.
And then ring also.
So on the other side of the spring, it is the force by the ring on the spring. That is what you're meaning, sir?
Yes, ma'am.
Yeah. So now suppose we take the entire balance. Now what happens to those two forces? Are they still acting within the system or not? Or they've disappeared from acting?
Ma'am, they are acting, but now our concern is on that complete system, so we will not taking much care of that.
So now those very forces have become internal to the system. Now, when we are taking a system, we are not concerned what is inside the system. Now we will consider only what is on the system from outside. Only the external forces are to be considered, right? So when we change the system, we change the force picture. We don't stop the forces from acting, but what we are seeing changes. So is this exercise explicitly done in the class to move the student from picturizing one situation and picturizing the other situation? Now let me go still one more step ahead. Now let's look carefully what happens. If we take the spring and we start from 1 Newton at one end, okay, and relate it to the force at the other end. What is the force at the other end of the spring? Suppose we take only the spring and start from The 1 Newton force that is acting on one end. Who is applying that force on the spring? That 1 Newton?
It is applied by the hook.
By the hook. Very nice. But now we go to the other end of the spring. Now, can you relate it to the force at that end? What is the force at the other end of the spring?
It must be same 1 Newton.
No, I'm not saying 1 Newton or not. I'm first asking you which force is acting on the other end of the spring. On one end it is by hook, and on the other end of the spring which force is acting?
Force by ring on the spring.
Yes. Okay. And now how these two are related?
They must be equal and opposite.
Okay. Now supposing we take the entire balance and we relate the external forces acting on the system. Can you still go from 1 Newton to the force on the other end of the system? So now imagine this whole spring balance as a system. What is the force acting on the lower end of the system now? What is the external force acting on the lower end of the system now?
1 Newton.
No, I'm not asking about the magnitude. I'm saying what is the force? Who is applying force?
Muscular force? Muscular?
Gravity.
Who is applying? Who is applying?
Muscular force?
Who is applying the force? No, you are applying, right?
I am applying, yeah.
But
on one end,
and
on the lower end,
other end of the system, top of the spring balance, what is the other force that is being applied?
on the lower end,
Varsha on the spring on the upper end, and on the lower end you are applying the force on the hook, or not hook anymore, now on the total spring balance. Now tell me, how will you go from your force that you are applying to the force which Varsha is applying on the system? Can you go still there? Can you reach her? Can you reach her force? And by what argument?
We should know all the interactions that are happening in the middle. So all the different
In the
layers.
middle, when will you look at those interactions? Will you look at them when you're considering the whole entire balance, or will you consider them only when you're talking about the spring?
Is the spring horizontal or vertical?
Vertical.
So we need to isolate each of those parts separately and analyze each of those
Yeah, so
separately.
that is what we are doing right now. That
No need to
once
look at the middle
when
part.
we
The
thought
Varsha's
about
force
only
and
this,
the applied force.
when we thought only about the spring, what was the force at the lower end? By the hook on the spring. And when you think of the upper end of only the spring, what is the force on the spring? It is by the ring on the spring. Correct?
Yeah, ma'am.
Now, from this knowledge that at the lower end of the spring, 1 Newton force is acting, which is applied by the hook, how do we reach the force that is applied by Varsha on the ring? Can we reach it or not reach it? Yes, we can. Because the force at the lower end and the upper end of the spring are equal. Why are they equal? Tell me why they are equal.
Varsha is holding the ring actually, and these forces are equal and opposite.
Wait.
These forces are
after
equal and opposite here.
Think of what is the system we are talking about. Right now we are talking about only the spring. Now keep that only in your mind, that you are only looking at the spring, nothing else.
Ma'am,
Arjun ki aankh.
on the
Yes.
system, 1 Newton force is acting, so that's why.
Who is applying that force and at which end of the spring?
Ma'am, lower end
By
hook.
By hook. And at the upper end, who's applying on the spring?
Ring.
A ring. So now, what is the relation between the force by the hook at the lower end and the force by the ring on the spring?
Balance.
So
There,
ma'am,
Equal
you're
and
saying
opposite.
equal and opposite. What makes you say that?
Because the spring is at rest after reading 1 Newton.
Okay.
Spring
Is
is in
that the only
equilibrium.
assumption, or you assume something else also?
Massless.
Massless. If it was not massless, what would you have said about the force which is acting at the top of the
There
spring?
might be some weight also.
Lesser than 1 Newton.
So force at the top will then be lesser than 1 Newton?
Yes,
In
ma'am.
which direction is the force applied by the hook on the spring acting?
Upwards.
By the hook on the spring?
Downwards.
Downward.
Hook
In which
downwards.
direction the weight of the spring?
Downwards.
And in which direction is the force by the ring on the spring?
Upwards.
Upward. So now tell me, will the upward force be
Greater.
Greater than 1 Newton.
Greater
than 1
Because of weight.
greater than 1? So you assumed it to be 1 Newton. You worked it out to be 1 Newton without even wondering whether the spring is massless or not. The answer by chance came out to be correct in case the spring was stated to be light. But if it is not stated to be right, the same answer will not be right. So if someone says 1 Newton is the answer and the other person says it is more than 1 Newton, both are right. But are they consciously right, or because they have understood the assumptions they have taken, or they are बेहोशी में राइट है कि हमने निकाल लिया आंसर, सही भी है हमारा आंसर, लेकिन क्या से आया हमें नहीं पता. क्या कैसे आया ये हो सकता है उनको पता हो, बट कॉन्शियसली क्या assumption उनको लीड कर रहा है वहां तक, आर वी क्लियर अबाउट? Now come back to the entire balance. Now tell me, now what is the force at the lower end of the entire balance? अब आपके सामने स्प्रिंग रिंग
Applied.
कुछ नहीं, आपको पता नहीं है इसके अंदर क्या है.
Applied force. Applied force.
By whom?
By the person, myself.
By the person. And how that force is related to 1 Newton force? What was
It
the
is trying to
force 1 Newton?
compensate.
What
It
was
is
the
trying to
force 1
compensate the force applied by
No,
Varsha.
let's go back. First thing we asked was what does this 1 Newton represent? Force by whom and on what?
Myself on hook.
Was that what we discussed? How does the spring get stretched? What acts on the spring? Is your
By
hand
hook.
touching the spring?
Hook.
Hook. So by hook on the spring is 1 Newton. But now when the entire balance you have taken as the system, is that force visible to you? No, it is inside now. So you have to now find out what is the external force on this entire spring balance, which is the force by your hand on the system. So how will you know how it is related to 1 Newton?
From the reading.
But reading is not telling you about your force on the system. It is telling you it was a force on the spring by the hook. So what is the argument by which you say that it is also the force applied by you on the hook?
The hook is massless.
Okay, and it is in equilibrium, or is it because of the action-reaction pair?
Action reaction pair.
Yes. The hook and the hand, they apply force on each other as action reaction pair. And the force by the hook on the spring and spring on the hook is also another action reaction pair. So you conclude from this argument that force by your hand on the whole system is the 1 Newton force. But it's not automatic. It's not automatic. It is this internal small process that we have to understand in our mind. And so do the children. Because only when they understand the system they have chosen, they need to write the force on that system. That force is not given. 1 Newton force is given to us, which is not the force applied by hand on the spring. So how do you move from what is given to what you need?
And this force may include weight also 1 Newton, if mass is considered there.
No, right now we are at the lower end.
Yeah.
And there the weight is not coming in picture because we are arriving at the conclusion through application of action reaction pairs where presence or absence of mass does it matter. Action reaction pair will always be equal.
Yeah. I'm talking about the 1 Newton force. If balance is reading 1 Newton force, then
No, let's not go there.
Weight
See,
also.
let's not go there.
Right.
Because this is exactly the pitfall, is that we want to reach the correct answer. The point is, it's not the answer which is important. The point is, it is the process of arriving at that answer which is important, because that tells us how to reach that answer. And that is what the children fail in. They understand what is action reaction. They understand what is the meaning of equilibrium. They understand the spring being massless, but they are not conscious that how these things are acting in this situation or how they have to be utilized or leveraged in this system to go from unknown to known. So we now, just when we thought of entire balance as the system, we have understood the lower portion. Now what force is acting on the top portion? If entire spring balance is the system.
Spring on ring. By Varsha.
By Varsha, because now spring and ring are not visible. They are internal to the system. Only thing that is visible is Varsha, the spring balance, and your hand. That's it. So now, how will you reach from your force on the spring balance to the force by Varsha on the spring balance? How will you say they are equal?
They are not equal.
No, how? When will they be equal? Why do you say they are not equal? Let's hear that, because if that is clear, then we'll be able to do the other thing also.
If the system is in equilibrium, they'll be equal.
Yes. Will only equilibrium ensure that the force by hand on the spring and force by Varsha on the spring are equal, or there is one more condition? Being in equilibrium means total of upward
Net force is
forces
zero.
should be equal to total of downward forces. So which are the downward forces? By your hand and the earth also.
Pull downward.
Right?
Massless.
So if you are assuming massless, then certainly the force by Varsha is 1 Newton. But otherwise, what? More than that. Now the point is that by using both the systems, whether you consider the spring balance, entire spring balance, or just the spring, you've reached the same destination, same answer, both have given. But the organization of thinking is different. Which one did you feel easier? The whole spring system, the whole entire spring balance to be taken as a system, or only when the spring was taken as a system? Which one you found easier?
Whole system.
Whole
Okay.
system.
So why did you find that to be easier? Think about it. Because their internal forces disappeared. So you could
Only two forces, yeah.
you could do away with many other action-reaction pairs on the path from the hook to the ring and then to Varsha, right? So both approaches are working, but they're organizing the reasoning very differently. In one case, we reason through the system, and in the other, we reason at the boundary of the system. So the question is not which system is correct, but the question is how do we want to organize our reasoning? Changing the system doesn't change what is happening, but it certainly changes how we describe it. So you notice we did not change the situation. We only changed how we chose to look at it, and that changed how we proceeded. Isn't it? In one case, we went from the hook to the spring to the ring to Varsha. In the other case, we went from our hand to spring and then spring to Varsha. So one path was quicker. So that is strategy. Which path should we choose? Whether we go through this path, then what is the way forward? If we choose to go from this path, then what is the way forward? And which one does it suit us? And why, what suits in one situation might be different, what suits in another situation. Okay. So the forces in reality did not change, nor the outcome changed. Both the times he got 1 Newton. So if two valid descriptions of the same situation give different answers, then what is the problem? Just now you saw whether you chose spring as the system or whether you chose the entire balance as the system. In both cases, the ultimate result was 1 Newton only. So we reached the same destination, same answer. But supposing we have taken two valid descriptions of the same situation, but still we got different answers. Is that possible in reality? The situation never changes, only our description changes. So if we are not reaching the same result, then there is a problem. And where might that problem be? Either our reasoning is inconsistent or the model itself is incomplete. Right? Because different systems can change the path, but not the result. You might have might think of Maxwell and Ampere circuital law. So when Ampere's circuital law was applied to a wire and to find the current, the magnetic field at one point near a wire through the application of Ampere's circuital law, and then on the same loop, but the current was threading through another surface. At the same point, the magnetic field came out to be different. And that is not possible. The reality cannot change whatever path you choose. So was the reasoning wrong? The reasoning was not wrong, but the model itself was incomplete. And which is what Maxwell chose to complete by modifying the law. So this understanding must be there. That result will be same, and we must try out by 4 different methods or 2 different methods. That can we reach the same result this way, that way, this way, that way? That gives us the flexibility in thinking. Okay, so now let us revisit what we just did. Using the spring, how did we connect 1 Newton of force to the force by Varsha? Force by Varsha. Remember, 1 Newton was the force by the hook on the spring. And then how did we reach the force by Varsha? By making certain assumptions. That is why those steps were valid. Right? We took the assumptions that the spring was in equilibrium or the whole spring balance was in equilibrium. Second, the spring is light.
Yes.
In first case and in the case of the whole spring balance system, the whole system was massless. Right?
Yes.
So what allowed us to say that was that, and what allowed us was the assumptions. But were they explicitly given in the question? Were they described in the situation? No.
No.
So the step was not automatic. It depended on something. What was that something? We were using the idea that spring balance is behaving like a light spring and the situation is steady. So choosing the spring did not change the forces we considered. No, it did not just change the forces we considered, but it determined what kind of reasoning we did, what kind of assumptions we had to take. In one case, we only needed the spring to be massless. In another case, we needed the whole spring balance to be massless. So choice of the system not only changes the forces we considered, but it also determines the way our reasoning becomes valid. And so system is not just what we include, it also determines what we are allowed to assume and what we are not allowed to assume. So this is the significance. Now let us go to still another situation. Now this is also a very simple situation. There are two blocks at rest, one over the other. We want to find out the normal on the upper block. That is what we have to find out. So now we have two options. One is we can choose the upper block to be the system or both the blocks together as one system. Which system would you choose? Upper or both? Just say it. Just unmute and tell me. What do you
Upper.
think? Okay.
Upper block.
Okay. So if we take the upper block, the normal force appears where we can find it. Where does the normal force on the upper block appear? Does it appear in that system or does it not appear in that system?
It appears, ma'am.
It
Appears.
appears.
It appears as what? By whom on what?
Balancing
By the block
the
below it.
weight,
Lower block
balancing
on
the
upper
weight.
block.
By the bigger block.
By the
lower
Lower
block.
block on
Lower.
Okay. Now let me ask you, could we instead take the lower block to be the system, only just the lower block?
Yeah, ma'am.
Then also will we get this normal?
Yes, ma'am.
We'll
Yes.
get the reaction of it, not the exact normal, but
So in that case, we will get it, but we will get it indirectly, right? Because
yes,
then
ma'am.
you will have to apply the instrument of Newton's third law.
Yes.
So even in such a small thing, the students can be made to see the advantage or disadvantage of one strategy and the other strategy. So we have to ask that even if we could take the lower block, would that help us to proceed directly, more smoothly or not? Now, supposing we take both the blocks together as the system. Now, what happens to that normal?
We are ignoring it because it's internal to the combination.
Now we can't find it at all because it has disappeared inside the system. We can't see it anymore. So the system we choose decides whether the force we need even appears. So here the question was not which system is correct, but which system helps us move forward, which is more fruitful for us. Now, suppose this same system is now pulled towards right through a string. Acceleration A is given, tension T in the string is given. And let us first choose the first unknown to find, friction on the upper block. So now suppose you want to find out the friction on the upper block. Which system would you choose?
The upper block.
Upper block.
Okay. So why would you choose that?
Ma'am,
Friction you need to find.
So the friction is an external force on it.
Okay. So that friction is the external force on it. And who might be applying that force?
Lower.
The lower one. Okay. So can we write any equation using that friction for the upper block?
Yeah, ma'am.
What would that be?
That the friction is equal to the mass of it times its acceleration.
Acceleration. So now my question is this friction necessarily equal to mu n? Supposing you did not find the friction by writing the equation F equal to m1a. Supposing you chose to find the normal reaction on the upper block, like we did in the last example, and then you wrote it as mu n, and then equated it to m1a. Wouldn't that be easier because you already have the result with you? What do you say?
We need to check if it's slipping relative to the lower block or not.
Correct. We have to check what exactly is the value of m1a. Is the force required to move the block m1 with acceleration a, that is m1a, is it just enough to accelerate it forward with a, or full static friction up till maximum its value is required to provide this? So it's not automatic that friction is going to be mu n. So now you see what are the kind of questions we are asking before proceeding. And if children, as a part of the daily strategy, if they learn to ask these questions, do you think they would go wrong less? Yes or no?
Yes, ma'am.
Yeah. Another thing, when we wrote the equation friction is equal to m1a, are we assuming something?
Only the upper body is moving.
Only the upper one is moving.
Ma'am,
But then A is the
no,
system's acceleration. Yes, sir.
no friction between ground and the M2 block.
Why? Right now we are considering the equation for the smaller block, no? That we have
But
taken the system. So does that force even appear there? The friction between the floor and the lower block, does it
No.
even appear in this system's consideration?
No, ma'am. If we take a upper block, then it would not take.
It would not. So we need not go there. I'm not saying right or wrong. We don't even need to go there. So when we are writing F equal to M1A, are we assuming something?
The acceleration is same, they are moving together because the system is moving with it.
Yes. So are we saying that the block is not slipping? Whatever is the acceleration of M2, same is the acceleration of M1. But is that always necessary? Can
No,
we
ma'am.
always take it for
No.
granted?
No, ma'am.
No. Now come to the second unknown, friction between the floor and the lower block. Now will you still take the upper block as your system?
No, ma'am.
No. Now supposing you took both the blocks as the system, would that force appear? Friction between floor and the lower block?
Yes, ma'am.
And what happened to the friction between the two blocks?
That won't be there.
That would be there, but we will not.
We will not consider it.
Yes, because now it has become internal to the system, and we are not concerned with the internal forces anymore, because whatever is our system, we have to see the external forces acting on it, right? So which forces will remain on this two block system now?
Tension force.
Mhm.
And if there is some friction between ground and the lower block.
Yes. And of course, in other directions, there'll be forces, but we are concerned only with the horizontal direction, right? So now you see what happened. To find the friction on the upper block, we use one system. But to find the friction between the floor and the lower block, we changed our system. Isn't it? Why did we do that? Because we had different needs. And so we chose whatever helped us to proceed. We don't need to stick to one system. We can use the system that helps us reach our final destination. And at each step, we are at liberty to consider another system. So, systems choice is not fixed, it is strategic. And it is this strategy that we have to bring to the focus of the children actively. Then only they will be able to see what are the different possibilities, and their minds will become flexible. And it is that flexibility which what expert problem solving looks like. What are the experts able to do? They can think about the same situation in 100 different ways. And our job is to make children do that. And how do we do that? We have to expose them to the technique. Now let us bring about a slight change. Same instrument, same reading 1 Newton. But Varsha now keeps the spring balance flat on the concrete floor and holds it by its ring. You pull its hook and stop when the balance reads 1 Newton. How much force, horizontal force, is Varsha applying at exactly that instant? So I am unable to launch the poles anymore. But kindly everybody make sure that you write in the chat box and don't worry about what other people are writing. Nobody is checking the correctness. We just want to let people think differently, bring in different thinking on the table, and then we will discuss each to evaluate where it was right, where it needed some more consideration. So, most important thing is in the classroom to give situations where children can think without any fear. First, we are not talking about the correctness. First step is just to get everybody to think in whatever way they are thinking. Because when the people think diversely, then only new things come out. We don't want everybody to think in the way we think. So do write in the chat box. One Newton, 1 Newton. Okay. C. What was C? C is 1 Newton. Okay. More than 1 Newton. Starting. Okay. Interesting. I can see some variety of thoughts there. So before we reach any final answer, let us understand the thinking. So would somebody care to discuss whatever you chose? If you chose, let's say, what I can see in front of me, greater than 1 Newton. So would you walk us through your reasoning that how you arrived at more than 1 Newton? Don't worry about being right or wrong. Just let us walk through that reasoning that you did in your mind.
So,
Yeah.
I chose the entire spring as a system.
Okay.
So the force by Varsha is to the left, the
Mm-hmm.
force by me on the hook is to the right, and the
Great.
friction force, assuming there's friction, is also
Okay.
to the left.
Okay.
So then when I write the net force equation,
Mm-hmm.
I realize that the force by Varsha,
Mm-hmm.
if I isolate it, it will become equal to force by me on the hook plus the friction force. And since the force by me on the hook is 1 Newton,
Mm-hmm.
if I add the friction force also, the force by Varsha has to be greater than 1.
Okay, so you're saying that the friction is towards you,
Towards Varsha.
towards Varsha. So then your force is getting added to your force is Varsha's force plus the friction.
Yeah.
So your force, so Varsha's force is what? Greater?
My force, Varsha's force will be my force plus friction. Wait.
Ma'am, if
Oh,
the system is in equilibrium, then
Wait, we'll finish with one. Wait, we'll finish with one, we'll come to another. So,
yeah, I just realized, ma'am. I think, yeah. So if friction is towards Varsha, then Varsha's force will be my force minus
no
friction.
worries. So,
So that'll be, yeah.
yeah. So the important thing is that when you tried it yourself, you realize that you were going wrong somewhere. So this
Hmm.
thinking that you're bringing to the table is what is most important. So let me ask you, what made you, did you take any assumption here?
That it is in equilibrium.
Okay.
And
You put your system
that
as the entire spring balance. You took the forces that you described, and now I'm asking you the third step. Was there any assumptions that you took? So one of them you said is equilibrium,
yeah, and that it's massless.
and that it's massless. Okay. Anything else? So would somebody else tell me, is there any other assumption that, may I know your name?
I'm Sashank, ma'am.
Okay. So can somebody tell us what other assumption, if any, Sashank ji might have taken?
Ma'am, can we take frictionless surface?
No, but has he taken frictionless?
No,
He has
no.
taken
He
friction.
has assumed friction.
Yeah.
He
So
has
now
taken
I'm
friction.
asking you that apart from the assumptions that he told us, equilibrium and massless spring, was there any other assumption implicit in his reasoning?
Ma'am,
That there is friction between them.
ma'am,
What about that?
ma'am, if he is considering friction, then the system should not be in equilibrium.
Why not?
Ma'am, because if there is relative motion between the spring balance and between the ground, then it is moving, and only then the friction force will come into play.
Why? If there is intended slipping, then also it can be there, isn't it?
Ma'am, is it internal forces cancel out? Because we are taking the entire system of spring, like hook, ring, etc.
Is that the assumption that needs to be taken? Those forces are not visible.
Yeah.
So there is no assumption that you need. Do you need any assumption for that?
No.
You've taken the assumption of your system, that I've assumed this as my system. So that's, but apart from these, what we have discussed, is there any other assumption that has been taken, but he's not aware of it, which he has taken? Okay, let me ask somebody else. Now, Rani ma'am, you wanted to say something. Let us consider your option.
Yeah, I was taking under the condition when there is no friction. So I was taking the entire spring system.
Okay.
And on that conditioning and massless, in that way, I was like taking this 1 Newton. But
okay.
Yeah.
So your assumption is clear that you are saying frictionless surface.
Yes.
And it is in equilibrium and there is
Massless.
no. Okay. So does that sound justified
Oh.
or not? It does. So you see, already we have two possibilities in front of us, and both of them are right. So do we discuss this kind of situation where multiple answers are possible? But we have to bring it to the thinking of the children that how the variety is possible. और क्या thinking आप है कि do you differ from this? Less than 1 Newton, equal to 1 Newton? Is somebody saying more than 1 Newton also?
I don't exactly differ, but because just like we have friction case also, we can have non-friction answer also.
So that we have
Yeah.
discussed already.
Yeah.
So let me ask, how was it assumed that friction is towards Varsha? Wasn't it as an assumption?
I was about to
Yeah,
ask
ma'am.
same thing. Yes, I was about to ask.
So could it have been towards you also?
If we'll take Varsha as a consideration.
Suppose when you applied the force, before that Varsha had already pulled the spring balance towards herself, then where would the friction would have been?
And we have to check whether we are talking on ground or spring balance.
On ground only. It is lying flat on the ground. So is it not possible that when you started pulling, before that only Varsha might have pulled it towards herself little bit. So in that case, friction generated would have been towards you.
Yeah.
And now when you apply the force together, your friction would have been more than 1 Newton. So Varsha would have applied more than 1 Newton. And is it possible that her force might be 0 Newton?
Yes.
When would that be?
Both of them when they apply 1 Newton force.
Or if there is no 0 Newton is the force applied by Varsha. That was the question, that what is the force applied by Varsha? So we are talking about
Friction
all
is
these
equal to
answers.
friction is same equal to the force applied by us.
Yes, there is so much of friction on the ground. वो कई बार ऐसी नहीं surfaces होती हैं जिसमें पत्थर पत्थर निकले रहते हैं. So maybe the spring balance has got so much friction over there that Varsha doesn't even need to apply any force, and you still can't pull it. So the thing is, some assumptions might be unlikely, but nevertheless, there is a possibility. And
If
our
you don't,
job is to just bring it to the notice of student that how we don't leave anything to chance and how we are able to do that. And
if we assume that the surface is frictionless, but it's not massless. It's in
yes,
equilibrium, but not massless. So then, how would it change?
so what do you think? How would it change?
The weight of the spring
Extends, probably.
and
How the mass is distributed.
But then in that case, it is in horizontal position and we are taking equilibrium. So weight is acting like वो भी situation we can have it.
हाँ,
you're not
आपके माइंड में
considering.
ये आ रहा होगा ना कि वेट तो
हाँ.
डाउनवर्ड एक्ट करता है.
Yes.
But equilibrium भी है अगर हम बोले.
लेकिन
But massless
हॉरिजॉन्टल डायरेक्शन में भी उसके मास का कोई इम्प्लीकेशन है.
tension, हाँ, yeah.
In the way the internal tensions act between
Yes.
one part of the spring and the other part of the spring, it
वो,
might have bearing on it.
yeah, वो vary हो जाएगा.
But what time
But
when it
for the
is
entire spring
stretched, or
balance, will it?
when it comes to rest, then also, or while it is being stretched, all these considerations we can go into. So what I'm saying is that we need to take the students through this journey. That is most important. And some of the times it's okay, even we might not know the answer. We don't have to know everything. So can we not collaborate with the students to discover more or strengthen even our own understanding more? It doesn't really matter whether we know the answers readily or we don't know them. What matters is that this effort to explore.
Ma'am,
It's perfectly fine to fail.
ma'am, can I add one thing?
Yes, sir.
मैम जैसे जो वर्षा फोर्स लगाएगी उसको पुल करने के लिए, तो वो ग्रेजुअली मतलब अगर अनदर पर्सन इज अप्लाइंग 1 न्यूटन फोर्स, तो वो उस हिसाब से अगर स्प्रिंग बैलेंस को मूव नहीं करने देना चाहती है तो वो लगाएगी। और अगर हम उसको कहीं हुक को अटैच कर दें टू अ बॉल और समथिंग, तो मैम फोर्स ऑफ फ्रिक्शन फिर उस कंडीशन में तो बिल्कुल हम उसके बारे में सोच नहीं सकते बिल्कुल।
सर मैं ये कह रही हूँ कि हम एक सिंपल सिस्टम लेके उसमें कंडीशंस इंपोज करते जाएं और सोचते जाएं कि क्या होगा। आप बिल्कुल सही रास्ते पर हैं। अब आप सोचें अगर वर्षा को हटा के वहां पर किसी जगह से उसको अटैच कर दिया जाए तो क्या होगा। वेरी गुड, लेट अस कीप ऑन इंट्रोड्यूसिंग मोर कंस्ट्रेंट्स, बिकॉज जितनी हम कंस्ट्रेंट्स लगाएंगे उतना ही इट विल अलाउ अस टू गो डीपर इन अ लिमिटेड सिचुएशन। जब तक हम कंस्ट्रेंट्स नहीं लगाते हैं तब तक हमारी थिंकिंग चारों तरफ छितरी हुई है। जैसे ही हमने कंस्ट्रेंट लगा दिया तो हम एक पर्टिकुलर एरिया में अपना हमारा फोकस हो गया। फिर और आप कंडीशन लगाते जाओ और कंडीशंस लगाते जाओ, तो हमारी डीपर एंड एंड नैरो होती जाती है हमारी दृष्टि, और फिर हम उसमें क्या क्वेश्चंस पूछते हैं उसके हिसाब से वो डीपर चलता जाता है. So what I wanted to say is that we began with a very simple situation, a spring balance reading 1 Newton. Okay? And yet we saw multiple answers, even when when it was vertical and even when it was horizontal. Just the way its orientation changed, when we, not only orientation, when we decided what will be our system, then something changed. Not that the situation changed, but our answers changed.
मैम
हाँ.
मैम
Yes.
ये जैसे हमने न्यूमेरिकल किया, अब जैसे इसको हम डेमो में ऐसे लैब में स्प्रिंग बैलेंस करके इसको करते हैं, तो वी कैन हैव डेमोज, मतलब उसमें एक्सपेरिमेंटली आल्सो विल हैव रीडिंग्स आउट ऑफ दिस डिफरेंट सिचुएशंस हॉरिजॉन्टली. क्या हम ऐसे कर सकते हैं?
करके देखिए. किसने मना किया, किसने स्टॉप किया
तो
हमें
उसके
करने?
रीडिंग्स जो है वो ऐसे, मतलब दैट विल बी लाइक दिस.
No, we don't know what it will be like this. I just took a hypothetical situation. The point is not the activity of demonstrating. Just by demonstrating something, people will not get it.
Yes.
Thinking is not ensured just by demonstrating.
Hmm.
Tool that we have at our disposal for getting the thinking out is the questions. The way we design the questions and the way we sequence them. The conceptual clarity is that boundary of concepts is defined by the curricula, by the books. As teachers, our job is to design that struggle, that thinking struggle that you just underwent.
Yes, ma'am.
Is our domain. That how we will design that thinking struggle in our classrooms, which will bring the rigor of thinking.
Yes,
The
ma'am.
problem is, the examinations in the classroom, by explaining so much, we are ensuring certainty. But the moment they sit in the examination room generates uncertainty. Now, if we have not taught the children to deal with uncertainty, to think in new situations, to make sense of new situations, by asking questions, first of all, not by answering the questions we have designed always. So, if we do not put them in uncertain situations, how do you think they will suddenly come up with deal with uncertainty in the exam or later in the life? By making everything simple to them, are we really helping them in any way?
No, ma'am.
So it's not about it's not about physics content. It is about how we use that content to develop the thinking. Same physics hai. Lekin how we choose to describe, we just saw that by considering different systems, we were able to describe the system in different ways. Now, every time we solve a problem, we are making decisions. And what decision we will make? यही ना कि कौन सा सिस्टम हमें चूज करना चाहिए, अगर हमने ये किया तो कौन से इंटरैक्शंस हमें कंसीडर करने हैं, क्या अजम्पशंस हम ले रहे हैं, कहाँ से हम उस सिस्टम को देख रहे हैं, क्या हम ऐसी जगह से देख रहे हैं जहां वो हम दोनों रेस्ट पे हैं, या हम में से एक एक्सिलरेट कर रहा है. अगर हम एक्सिलरेट करने लग गए तो क्या होगा, क्या हमारा डिस्क्रिप्शन वैसा ही रहेगा? Now, all these discussions and decision points are not written in the questions, but they completely shape our answers. And this is what remains hidden in our classrooms. Students see the steps, but not the decisions behind them. And if we want to build real competency, we have to make this thinking visible, how we are taking decisions, especially for the weakest students, because that is where they require, that is who requires is the most. They don't need more problems. They what? They need clarity of thinking.
So, ma'am, would you say that's scaffolding basically? So we have to
Exactly.
move. Okay.
Exactly. That is our job. How to design for that scaffolding, how to plan that scaffolding before going in the classroom. So today we did not learn any new formula. Probably you knew everything. But we learned how to approach a situation, to decide what we are analyzing, how we are describing, what assumptions we are making, because we are sure that in physics situations don't change, how we describe changes. So thank you so much for thinking with me today, and hope to interact with you more tomorrow.
Thank you so much, ma'am. Very, very helpful.
Thank you, ma'am. Thank you.
Thank you so much, ma'am.
Thank you so much, ma'am. Thank you.
Really, it was a very thought-provoking and insightful presentation, ma'am. It was very nice session. So you really made us think in a very clear way.
We went beyond the time. It's
Really, ma'am, the discussions on the spring system,
staying
two
for
block
so
system.
long. Thank you for staying with me so long.
It's our pleasure. And I was just looking at that the participants are really enjoying and having a very good interaction. The discussions on spring system, two block system were especially engaging and beautifully explained. Ma'am, you really made the concept very clear in a very interesting way. We sincerely appreciate your effort and valuable contribution to today's session. So, dear participants, as we conclude the first day of our 1 week online workshop, I, on behalf of organizing team, would like to express sincere gratitude to all the esteemed guests, resource person, dignitaries who joined us today and encouraged us with their valuable presence and insights. Your support and guidance have been truly inspiring. I would like to extend my heartfelt thanks to all the participants for your enthusiastic participation and active engagement. Your presence truly made today's session meaningful and enriching. Now, we kindly request you to take a few moments to fill out the feedback form, as your valuable inputs will help us to improve and make the upcoming sessions even more impactful. Also, for your convenience, the recording of today's event will be shared on Google Classroom. We encourage you to go through it and revisit the key learnings. So once again, thanks to all, and looking forward to your continued participation in the coming days. Thank you.
Thank you, ma'am.
Thanks, ma'am.
The link is shared, and I will share the link in the WhatsApp group too, for your convenience. Thank you.
I'll share a small quiz on the Google Classroom.
Pardon, ma'am?
Shall I share a small quiz on the Google Classroom?
Yes, you can share.
Yeah, ma'am, you can.
Oh, okay, I'll do that.
Okay, let me close the session, and should I end it with your kind permission?
Yes.
Okay,
Thank
bye-bye.
you.
Have a nice
Thank you,
time.
Neetu.
And
Thanks
good
to
night.
everyone.
Good night, everyone.
Thank you.
Okay, bye. Meet you tomorrow.